one, the first thing is to rewrite the radical, because that's always what we do for derivatives, antiderivatives, rewrite the radical. And you will notice this is a definite integral because we have bounds. So once we rewrite the radical, we see parentheses, so those parentheses indicate to us that we need to use u substitution. We usually pick the quantity inside the parentheses as our u. So our du, derivative, we drop things, so the constant is going to drop to 0. The negative x squared becomes negative 2x dx. All right, so we focus on switching it to u. So the first thing to start with is the definition of u. So u is 1 minus x squared. So all of this becomes, by definition, u to the 1/2 power. Now, that leaves us with the negative 2x dx to get for our du. So when I convert that to u, I'm left with x dx, and I have 0 to 1. All right, so to get my du, I'm going to take and multiply in by a negative 2, and so that will give us a change to the integral, so we divide by negative 2. So now we have the negative 2, the x, and the dx. So all three of these factors multiplied together become our du. So all of this is our du. We still have the u to the 1/2. We still have the negative 1/2 and the integral sign. Now, we've got to talk about these bounds. These bounds up here, when it's in terms of x, that represents x is equal to 1, x is equal to 0. Now, you could go off to the side and convert to special u bounds, but so the process is the same as the indefinite integral. I am not going to convert to special u bounds. I am just going to have kind of a placeholder of u1 and u2. Okay, but again, you could convert it to the actual new u bounds, but what I'm going to do is I'm just going to say u1 and u2. All right, so now the integral is all in terms of u, including the bounds, so we are ready to integrate. So the negative 1/2 is going to tag along. We add 1 to the exponent, that gives 3/2. Dividing by the new exponent means we'll flip the fraction and get 2/3. Now, instead of writing a plus c, because we have these bounds, we're going to put our bracket and say it's u1 to u2. All right, now before we switch back to the original variable, I would cross out these little 2's and say that you're looking at negative u to the 3/2 over 3, and then u1 to u2. Okay, so I successfully integrated here, and now I am ready to switch back to the original variable in terms of x. So I used the definition of u, and the definition of u was 1 minus x squared. So in for this u, I plug in the 1 minus x squared, and then to the 3/2 power over 3. Now, at this point, I am now switched back to the variable of x. So I can also switch the bounds back to the x bounds. So I'll go from 0 to 1 as those were my original x bounds. All right, so now what I have to do is I have to use my fundamental theorem of calculus to evaluate this definite integral. So I have the bound of 1 as the upper bound and then the lower bound of 0. So remember, from the fundamental theorem, we take the upper bound minus and then in bracket the whole lower bound. So I'll start by plugging in 1. So I have 1 minus in for x squared. I have 1 squared to the 3/2 power over 3 minus, and then technically you don't need the big old bracket because you just have one term here, but for practice we'll put the bracket negative and then 1 minus, plugging in 0 for x now, the lower bound, to the 3/2 power over 3, and then close that lower bound bracket. Now, this is one of the most frequently missed issues that people have. They oftentimes say, oh, I'm plugging in 0 so the whole thing goes to 0. That is not the case here. So really do the arithmetic. Do not just assume that if you plug in 0, it's all going to go to 0. So here I have inside of this parenthesis, again, order of operations, start with the parentheses. I have 1 minus 1, so this is going to evaluate to 0. So I have 0 to the 3/2, so it's over. This is going to be 0. Then I have minus. Now, inside of this bracket, I have 0 squared, so I can ignore that. I can ignore the negative, and I just have 1 to the 3/2 power. So that gives us negative 1 over 3. And then my final step is to get that double negative and just say that it's a positive 1/3. So our definite integral is evaluating to positive 1/3.